To remove error, what we can do is, suppose I am driving a car. I am giving enough acceleration. My set point is 60 kilometers per hour. Car speed also 60 kilometers per hour. What is the error? Set point is 60 kilometers per hour. Car speed also 60 kilometers per hour. Now the error is 0. Some wind is against car direction now. Therefore, the speed is decreases to 55. Speed is decreased to 55. What I will do? I'll increase the acceleration, not set point. Set point is 60 only. Cross variable is 55. That's why I'm giving excess acceleration. Now it becomes 60. Now it becomes 60. I gave excess acceleration. Remember that. I gave excess acceleration. That's why speed becomes 60. Depends upon the error. I gave some output. Error becomes 0. Another time, I am driving the same car. I gave enough acceleration. The speed is 60 kilometers. Wind is heavy. That's why it reduced to 50 kilometers per hour. Wind is heavy than yesterday. That's why the speed becomes 50. Now what I will do? I'll give extra than yesterday. Now again it becomes 60 kilometers per hour. I gave extra input. Acceleration. That's why car speed again becomes 60. But here our mind know how much input we have to give that extra so that the error becomes 0. What is the mathematical expression for that extra? Yesterday, the error becomes 5 kilometers per hour. I gave some extra. That's why it becomes 60. Today, the error is 10 kilometers per hour. I gave some extra. Now the speed becomes 60. What is the mathematical expression for the controller out? I gave controller out, extra controller out. M of t equal to what? M of t equal to something. M of t equal to yesterday function of 5 kilometer per hour. Today, M of t equal to function of 10 kilometer per hour. Today, it is function of 10 kilometer per hour. That is the difference. Here also, it removed the steady state error. Steady state error equal to 0. Here also, steady state error becomes 0 because the speed becomes 60. The speed becomes 60. The set point equal to what? 60. What is the speed before giving controller? 55. That's why I gave function of 5 kilometer. That's why it becomes 60. Earlier, now the wind is against severe. That's why it becomes 50. Now I gave function of 10 kilometer. It becomes 60. Steady state error becomes 0. What is the mathematical expression for this? What I did mathematically? Can you explain? What I did mathematically? This is what is there error now? Is there any error now? No. Then we are giving additional input, Earlier it was 10 kilometers per hour error. That's why we gave some input. By additional input, still I am giving. That's why car is running at 60 kilometers. What is the mathematical expression for that? How we can write that function of 10 kilometers? Function of old error. Error not now. Error is not now. Error is old. For that error, I am giving input now. Therefore, it is function of old error. How it can be done mathematically? Suppose let us assume that disturbance come here 60 kilometers per hour. Let us plot for error versus time. Error versus time. At 60 kilometer, error is 0. Suddenly at this point at T1, wind is against the direction of car. That's why it deviates. It deviates. And no controller means it goes to, the error is 10 kilometers per hour. The error is 10 kilometers per hour. But if controller is there, I can bring back to 60 like this. I made like this without any oscillation. When I am driving, suppose you are driving means you can bring without any oscillation, you can bring to 60. So This is with controller. This is with controller. This is with controller. This is without controller. This is without controller. This is without controller. It goes to new speed. Controller means it with controller. With controller. Error becomes 0. How to find mathematically that value? It is function of old error. It is nothing but if you integrate the error, what you will get is, if you integrate the error, you will get area under this graph you will get. Therefore, m of t equal to integral of e of t dt. E of t dt. That is, if you multiply by some constant, say kc by ti, then it is called integral controller. It is nothing but integral of error. Integral of error. If you integrate that, if error becomes 0, there won't be any increase. Because if you integrate up to this, there will be increase in controller output. After that, there won't be any increase in controller output. Because error is 0. You are integrating the 0. Integrating means adding. Adding 0 means it will not increase. So integration means you are adding the error. Literally, meaning of integration is adding. You are adding the error. Every point you are adding the error. But error starts decreasing because control output increases. What will happen if control output increases? Error starts decreasing. That's why gradually error decreases. At one point, error becomes 0. You won't give sudden increase in acceleration. Gradually, you will increase monitoring the speed. If it becomes speed, if the speed becomes 60, you won't increase further. That is the idea. You are integrating the error. You are integrating the error so that the controller output is sufficient to make error equal to 0. Controller output is sufficient to make error equal to 0. That is called integral controller. That is called integral controller. So you need an integral controller to remove steady state error. To remove steady state error. I'll discuss about integral control further tomorrow.